Hey scholars, I hope your semester has gotten off to a great start. Last week we learned about some properties of parallelograms. Well, today we're going to go a step forward and talk about some more properties of special parallelograms. These are rectangles, rhombuses, and squares. So they'll have all the same properties as parallelograms and then a few extra ones. So just make sure you're taking good notes and paying close attention. Let's get going. So remember, all quadrilaterals have four sides and therefore four angles. And based off the interior angle sum theorem, remember when we say n minus 2 times 180 degrees? Well, 4, the number of sides, 4 minus 2 times 180 is 2 times 180. So all quadrilaterals, their angles will add up to 360 degrees. So all these quadrilaterals, all these different types you see here, all these angles in them will add up to 360 degrees. Now what we see here is just a general quadrilateral. It has four sides. There's nothing else really too special about it. In the next lesson you'll learn about kites and trapezoids. And we've already talked about parallelograms. Remember they have two pairs of parallel sides. But today we're going to talk about special parallelograms. Rhombuses, rectangles, and squares. So let's move forward and talk about those things. Now a rhombus is a parallelogram with four congruent sides. So it has all the properties of a parallelogram that you learned about last lesson, but additionally all four of its sides are congruent. A rectangle is a parallelogram with four right angles. So the opposite sides, they're parallel, but in this case not all four sides are congruent, but all four angles are congruent. They're all 90 degrees. And 90 times 4, right, is 360 degrees. This is going to be silly, but let's say we have a mommy rhombus and a daddy rectangle. You know, they've fallen in love. A beautiful thing happens when they fall in love and they make baby square. So, you know, when a baby is made, it has properties and traits of its parents. So a square has all the properties of a rhombus, so it has four congruent sides, and it has all the properties of a rectangle. It has four right angles too. So if you combine the properties of a rhombus and the properties of the rectangle, you get a square. And a square, as we've talked about last quarter, a square is a regular quadrilateral. It's equilateral, four congruent sides, and equiangular, four congruent angles, 90-degree angles. All right, now make sure you get the properties of a rectangle. So it's a quadrilateral with four right angles. It's a parallelogram with four right angles too. And the diagonals of a rectangle are congruent. Remember that because a rectangle is a parallelogram, the diagonals of a parallelogram bisect each other. So that's going to be true for the rectangle too, except those diagonals are also going to be congruent. So if this diagonal, AC, is congruent to this diagonal, BD, then and they bisect each other, all four of these parts of those diagonals are congruent. Okay? So there we go. So those are the properties of a rectangle. So let's try a couple problems applying those properties of rectangles. So we're looking at number one, what is the length of RT? Well, what we're given is that SA is 5. So let's say it's 5 units. So that's this whole diagonal. Well, that property we just learned is that the diagonals of a rectangle are congruent. So RT must be congruent. Say RT is congruent to SA. And if the length of SA, well, we'd say the length of RT, let's say this, the length of RT equals the length of SA. We know the length of SA is 5. And so then the length of RT would be 5. And let's say 5 units. The length of RT is 5 units. I'll just say 5U for units. Now there's a lot of different ways we can solve for number 2. Remember, we're trying to solve for x right here. Now, one way we could look at it is we could see that, okay, we have a straight line here from A to T. So that we have two angles here that would make a linear pair. Well, if this is 60 degrees, then this angle must be 120 degrees right here. Okay, so that angle at the top of that triangle would be 120 degrees. Now, we know that the diagonals of a rectangle are congruent and they bisect each other. So like I said earlier, all four of these parts of these diagonals are going to be congruent. So now check out this triangle, triangle SZA. Well, what kind of triangle is it? It has two congruent sides, doesn't it? So it's isosceles. So we know that this measure, if this is x, then this would also be x. So we can say 120 degrees plus x. So x plus x is 2x, right? And we're looking at this triangle here. They should equal 180 degrees, right? So I'm going to subtract 120 degrees. We get 2x equals 60 degrees. Divide by 2, x equals 30 degrees. So, using the properties that we've just learned about rectangles and what we remember about isosceles triangles, we were able to find the value of x. It's 30 degrees. Pause that. Now, remember, a rhombus is a quadrilateral with four congruent sides. The diagonals of a rhombus are perpendicular and bisect the angles. So, get this. The diagonals of a rhombus are perpendicular. So, perpendicular means where they intersect, they form 90-degree angles. All these angles are 90 degrees. So, the angles right here where the diagonals bisect, they form 90-degree angles. They are perpendicular. They also, these diagonals also bisect the angles. Okay, they cut them in half. So, remember, it's a parallelogram, so the opposite sides are going to be congruent, or sorry, the opposite angles are going to be congruent. And those angles are bisected. They're cut in half. Remember, a rhombus is a parallelogram, so it also inherits all the properties of a parallelogram. So we're looking for the length of RS, and we know that the sides of a rhombus are congruent, right? So all four sides are congruent. Well, in order to find the length of RS, we need to find the value of x. Well, we can just say 9x minus 11 equals 4x plus 7, since those are congruent. So let's just solve this equation. Minus 4x minus 4x. We get 5x minus 11 equals 7. Add 11 on both sides. And we will get 5x equals 18. If we divide by 5 on both sides, we'll get x equals 3.6. Well, now we're not done. We found that x equals 3.6, but we're trying to find the length of our s, so we need to substitute that in. 9 times 3.6 is 32.4. Minus 11, that's going to give us 21.4. All right, now let's see if that checks out with the length of ST. Remember, they should be congruent, right? So we should get the same number when we substitute here. So 4 times 3.6 is 14.4 plus 7. Well, that's going to give us 21.4. So this checks out. So the length of RS is 21.4 units. We weren't given a unit, so let's write units. That's the length of RS. Now, number 2. This one might be a little bit tougher. What is the measure of angle S? Well, let's think about it. What do we know here? We know that the diagonals of a rhombus, they bisect each other. And where they bisect each other, they are perpendicular. They form 90-degree angles. So, here's the deal. We know this angle is 90 degrees. So what we can do is solve for y by saying 2y plus 10 equals 90 degrees. And then all we got to do is find that value of y and substitute it in here. Okay? So let's do that. Let's solve this. We can say subtract 10 on both sides, and we get 2y equals 80, and divide by 2, we get y equals 40. Well, now that we have found y, just by knowing that this is 90 degrees, found y, we're going to substitute it back here. 40 plus 2 equals 42, and then don't forget this degree sign here, 42 degrees. The measure of angle S is 42 degrees. Now lastly, let's move on to squares. A square is a quadrilateral with 4 right angles and 4 congruent sides. The diagonals of the square are congruent and perpendicular. It gets the congruent diagonals from daddy rectangle, right? And the perpendicular diagonals from mommy rhombus. Okay, so it has all the properties of rectangles and rhombuses. So let's check out this diagram of a square. All 4 angles are congruent. They're all 90 degrees. All 4 sides are congruent. And you can see that they have perpendicular diagonals. Okay? They form that 90-degree angle there because they're perpendicular. Now we're not going to actually work problems with the properties of a square, but we're going to think through some statements. We're going to use some logical reasoning here. We want to identify each of these statements as either always true, never true, or sometimes true. Okay? So let's look at number 1. A rectangle is a parallelogram. Well, is that always true, never true, or sometimes true? You're right. It is always true. Think about our flow chart. Parallelograms at the top, and below, underneath that umbrella of parallelograms, is a rectangle. A rectangle has all the properties of a parallelogram. So this is always true. A rectangle is always a parallelogram because it has all of the parallelogram's properties. A rectangle is a square. Well, a rectangle has 4 right angles, right? But it doesn't always have 4 congruent sides. If that rectangle also had 4 congruent sides, then it would be a square. So there are cases where a rectangle does have 4 congruent sides, making it then a square. But a rectangle may not always have 4 congruent sides, so this is only sometimes true. It's only sometimes true. Now number 3, a square is a rectangle. This is like a rectangle being a parallelogram. A square is a rectangle because it has all the properties of a rectangle. Okay, so a square is actually always a rectangle because it has the 4 right angles that a rectangle has. So number 4, a rhombus is a square. Well, this is kind of like number 2, saying a rectangle is a square. This is sometimes true. If that rhombus, which has, a rhombus always has 4 congruent sides, right? But if that rhombus also has 4 right angles, then that would make it a square. Okay, so that is sometimes true. So I might give you some problems like this in class where you kind of have to think through some of these statements like this. So I hope that video was helpful for you. Come to class with questions and ready to practice what you've learned. Good work today. Thank you, collegiate scholars.